In this video, I add the option of running my portable fridge off cordless drill batteries, in particular Azeto. So to begin with, I went onto Thingiverse and I found a breakout connector for Azeto 18V batteries. I then loaded this into my Creality 3D printer software and created a file and then printed it out. These little printers are really good. I had one a few years ago and it was very hard to keep running, like I spent the whole time just getting it to work. Those new Creality printers are amazing. It has never failed to print on me. All I do is load the file into the software, click slice. The only setting I really change is whether it needs support or not. Put it in the printer, push print, and it pretty much just works every time. So to get the power out of the battery, obviously I needed some little metal pins that connect into the battery. So to do that, I used an old charger off another type of power tool I had. And I got the little pins out of it, which were perfect for this job. So I just cut them straight off. I no longer need this charger. I don't think it even works anymore anyway. So I just got the original print out that I did, the first print, and I tested with these pins in there. I wasn't really happy with the design of this breakout connector, so I decided to redesign it myself. After just playing around with this one and just having a look how the pins are going to work and see what the best way to do it would be. So I didn't like it how the pins were sitting on top and you could see the cables coming out. So I went back to the drawing board, I redesigned another one in some CAD software, then put it back into 3D print software and printed it out again on my Creality printer. So this one's the V3 SE printer. It's one of the newest ones, I think, the V3 version. So you can see my new design compares to the old one. It's got the 4 screw slots and without the big wings on the side. Also I have the ability to add the pins in from the back now, which is much neater, so the cables can be soldered in on the back end, coming out the back of it so you can't see them. So this was just a quick test fit of the battery on the breakout adapter and to make sure I was actually getting power out of it. So I put a multimeter on there and you can see I'm getting 19.74 volts, so that means it's working. So now I just have to solder the wires onto the back of the pins here, just with my makeshift holder using a pair of pliers. I might actually 3D print out a proper soldering holder at some point. This will do the job for now. So there's another test fit with those on there and you can see it works quite nicely. There's cables coming out the back of it and you'll only see the pins on the front and that's it. Much neater design. So I just had some little screws and screwed it in through the existing holes on the connectors there. So now that I had the connector worked out, it was time to actually open up my fridge and start fitting the wiring inside of it. As you can see, there's a fair bit of old dust sitting there. This thing's done some miles, this fridge. It's done a full trip around Australia in the outback, getting covered in dust. Doesn't let me down though. It's only a cheap little fridge. I only paid about $280 for it. So actually I had to pop off the cover here too, so the little LCD display. There's a couple more screws under there. Took me a little while to work out, but I had to do that. So once I got those screws out, I could just pop the entire side off, which made it easy to access the internals. You could see the whole compressor and everything and all the plugs and everything. So I just decided to run the cables out the back through the slots that are already on the side of the case there. And then I could just get my drill and screw it straight in through the plastic with some small screws. This fridge can run on 12 or 24 volt batteries. It automatically detects which one you're using. And if you're using a 24 volt battery, it will shut down automatically when the voltage gets below 20 volts. That's the reason I need to use a boost converter for this situation. So because the drill battery is only 18 volts, the fridge thinks it's too low and it'll shut down. So what this boost converter does, it boosts up to 26 volts. As you can see here, I'm winding it up. So this will supply a constant 26 volt to the fridge so it doesn't shut down. So the reason this protection is in place is because lead acid batteries can be damaged if their voltage gets too low. But I only use lithium batteries which have a battery management system, including these drill batteries. So that means I don't need this protection, as the battery management system will do that for me. So as you can see here, I just cut the main input cables that go into the side of the fridge where you normally plug your battery into, and put them to the output of the boost converter. This does also mean that when I connect a normal battery, 12 volt battery into the input, it will also get boosted to 26 volts. The only real drawback to this is that you do lose some efficiency. These converters run at about 93% efficiency according to the specifications, That might not be 100% accurate, it might be a bit worse than that, I'm not really sure. But generally it's at least 90% efficient. But I'm okay with that because of the extra convenience of being able to use my drill batteries. So now I just made out some other cables that plug directly into where the original cables were. And obviously I've got a 10 amp fuse in line there, protect the input side. This is just a negative cable now I'm plugging in. So I did that first, and also did the same thing on the 18 volt drill input side here. I found these good little connectors that just seem to snap in. So you just feed your positive and negative into it, and then you can use your pliers and just close it up. That's it. Very easy. I did the same thing, and then on the other side you can just plug them in together, as you can see. So on this input I've also got a 10 amp fuse, as you can see there. Obviously it's always good to have your connection there just in case anything happens, you don't burn up all your cables. So these both go into the input side of the converter together. It's a little bit hard to fit them in there. I probably would have been better off using some sort of ferrule crimp or something to make it easier, but I managed to make it work. Did them up nice and tight. So now that that was all wired up, it was time to test out the battery and see if it worked. So I'll just turn it on, and you can see we're getting 26 volts there. It's currently 27 degrees inside the fridge. It all seems to be working so far. So there's another fuse here also on the input as well, coming out of the converter, so to make sure that side's protected. So I put a clamp meter on here so I could check how much current was coming out of the battery while the fridge was running. It was pulling around about 3 amps, so that's about 60 watts. So I've been running this fridge for about 20 minutes. On the display here you can see we're still getting 26 volts coming in. And we're down to 7 degrees now. I started at 27 and the compressor just turned off just then because it hit 7 degrees. So what I'm going to do is I'm going to measure the temperatures here, see where we're sitting at. 38 degrees actually. I'll check the coil in the middle. So the coil in the middle is about 46 degrees, so that's getting fairly hot. So what I'm going to do is put it behind the fan here. I just want to mount it. Put it up in here behind this fan so it gets airflow on it, and hopefully that should keep it down from getting so hot. So this converter is rated for 15 amps, but I'm only going to be pulling about 3 amps through it from that battery, and at this side is probably only like 1 or 2 amps coming out this end. So it should be well within its specs, but it does still get warm, so I think you definitely still need a bit of airflow on it, which is why mounting it behind the fan is a good idea. So I decided the easiest way to fix this thing on was just to use some foam tape. So I stuck 2 pieces of foam tape together, and then I put it straight on top of the compressor, a nice flat surface. It's not quite flat, but the tape molds around it and holds it quite nicely. So once that was in place, came along with some cable ties and just tidied up all the cabling, because you want to keep it all nice and neat so it doesn't jumble around in there and come disconnected once it's all together. See some little mini zip ties there. So I've stuck it up here on top of this compressor tank. It's kind of like on a bit of a 45-degree angle, so that the airflow will come through here through this fan, and it will kind of hit the tank and come up and flow over top of the converter. Now it's all done, so now all I have to do is put it back together and do some testing. It was pretty quick and easy to put it back together after I worked out how to take it apart. It's only just a few screws and we're all done. Now the final step was actually test how long the battery lasts for. So you can see here I've got a little voltage display there, so I can see the voltage of the drill battery as well while I'm doing this test. So what I did first was I plugged it into power with a little power adapter there and got the fridge down to 5 degrees Celsius first. Or actually it's 3 degrees Celsius. I just thought it was fair because when I'm using this, most of the time I'll plug it in first. I'm at home, put all my food and stuff in, and then take it with me. You can hear I push the button, you can see we've got a full charge there on the battery. So now we have to plug it in and test it and see how long it runs for. So we've got 20.6 volts there on the drill battery, and up on the fridge there you can see it's actually showing 26 volts due to the boost converter. So the little voltage display there beside the battery also shows the temperature of the shed. By the end of the test it got up to about 34 degrees and the battery lasted 4.5 hours. You can see on the top display there, the fridge was cycling up to 7 degrees and then back down to 2 degrees and back up to 7 degrees. I had it set to 5 degrees Celsius, so the compressor was keeping it around that range. So I'm super happy from the results I got from this. As you can see there, with this 4 amp hour battery, runs for 4.5 hours. So that's more than enough for me for what I need it for. So you might be wondering why I want to do this. Well, for me it was just when I want to go to a barbecue or a picnic or something like that, instead of having to take an esky with ice, all I do is I chuck this little battery on, throw my drinks in, and I'm ready to go.